Hello legends. In this video, we're going to be doing a deep dive into Webhook security. So we're going to be looking at 3 layers of security, starting with the server, then the webhook, and then the workflow. Now, the reason that I'm tackling this from these 3 layers is that when you self-host n8n and you get a request into your webhook or your workflow, someplace to be processed, the request has to actually pass through all these layers. First, it has to pass through your server. So you actually have some protections that you can do here. And if we just drill into this webhook, the server is what is responsible for, firstly, this URL that you see here, this actual string. The server is responsible for this, and it's also responsible for this HTTPS or this HTTP method. So when you're first deploying n8n, it actually defaults to the HTTP. This is like sending a postcard via the mail, where the mailman can literally pick up the postcard and they can see your private message. And it's like putting your bank information, your personal address, like all that stuff on the postcard. Well, anyone can see it. When you use HTTPS, this protocol is more secure. In the same kind of analogy, it's like sending a postcard, but in an envelope. So obviously people can tear open the envelope, but imagine it was like unterrible or whatever. Now someone cannot actually see your hidden information inside it. So it's a more secure protocol. So we're going to be starting off with the server. Now, if you're self-hosting n8n and you followed n8n's instructions, something like this, most likely you do have it secured anyway. But I found in my experience when I first self-hosted n8n, it was a bit of learning to actually understand all these different moving pieces. So I'm actually going to be explaining to you at a high level how Docker works, what are these different containers that you're installing, what they do, and how they interact with like an external service on the internet. This is just to give your hands a grip on the steering wheel so you know what's going on. And also just to dot our I's and cross our T's, just in case there's something that's not configured correctly here. So once this request passed through our server, the next line of security is actually at our webhook. So back at our webhook, there's a lot of videos about this already on YouTube, so I'm not going to try and reinvent the wheel. I'm just going to glide through here at a high level. I'm just going to choose something like header auth, show you how to set it up, and then we'll be done with this section. So that means we've got the server, we then have the webhook security, and now our final layer is once we pass the webhook, we can actually put some workflow security as well. So that's where we start looking at the rest of this workflow. So for example, when we have the webhook, this is the API key that we set. So like, let's say you have a bank card and you've got a PIN code. This is the actual PIN code that we set ourselves if someone wants to interact with our system. But there's also another way that you can set a PIN code. For example, like a secret signature, which would validate that what you're receiving is from the person you're expecting it from. So like Stripe, GitHub, Twilio, they would all use this signature method. To get this signature method, we have to build it into our workflow. So I'm going to explain this. And while we're here, we're going to be looking at different kind of data or payload validations as well. So once the data is actually in our payload, we can still deconstruct it and make sure like, hey, is this the data that we're expecting for this payload? And if it's not, we can just throw it in the trash and not actually process it so we don't break our workflow. So we're not consuming credits for no reason, so we're not infecting our database. And there's other ways within the workflow that you can also provide these additional layers of security or even just data validation. So at least you make sure you're working with the right type of data or the right event, or that you're working with the data that you're expecting. So that means in this video, we're actually looking at all these 3 layers, and I think this probably will be the most comprehensive webhook security video you would see online. So you might be asking, why is webhook security so important? I would say it's like having a bank card with no PIN code. If you have a bank card and you lose it somewhere and someone happens to find it, then they can go to the bank, they can touch your card on any ATM and withdraw all your money. So as a security layer, you put a PIN code on your bank card. So that way, if someone finds your bank card, they cannot just go and to any ATM. They have to have your PIN code. Now, if they do have your PIN code, maybe they're watching over your shoulder and they take your wallet. Then, as a second security layer, you can actually set a daily withdrawal limit. So someone does take your bank card and they have malicious intent. They can put your PIN code and they can withdraw $50. But if you set a limit of $50 per day, they actually can't withdraw anything else. So you have enough time to react and cancel your card. So that's why we want to install as many PIN codes as possible into our instance and into our workflows. Because if I was to ask you like, hey, would you put your bank card online somewhere? The likelihood of someone finding your bank card is super low. So do you want to leave it without a PIN code or with the PIN code? Most likely you'll be like, nah, I don't want to take any chances. I will put a PIN code on my bank card. Okay, so the first place we want to look at is the server. So I've just followed these instructions for n8n. So this is deploying on Docker on DigitalOcean. If you don't have the similar setup, maybe you can just take what I'm saying and put it into ChatGPT. But at a high level, these instructions actually tell you to pretty much do 2 things. When you install Docker, imagine Docker is like a computer, and n8n is saying to install 2 programs, a program called Caddy and a program called n8n. And n8n is what we're using. We all know what this tool is. But what is Caddy? What does it do? So let's say we have the computer, which is Docker. We install our n8n program or an n8n container, and this holds all the stuff that we're familiar with, the user interface. We go on, we play the workflow, we get interactions with the workflow. All that stuff is in this container. Then we have this thing called Caddy. So the Caddy container, this is like the bouncer at the nightclub. So Caddy is called, it's a reverse proxy, and a reverse proxy is like the air gap between n8n and then the outside service of the internet. So when you first deploy n8n on Docker, technically it could be accessible by anything online, and you want to put an experienced bouncer in front of your n8n. So if anything comes in from the internet, you're making sure like, hey, who are you? What are you doing here? You want to confirm the identity. Also, you can use the analogy of like an office. So let's say you go into like this high-rise building, lots of offices. You can't just go into the 5th floor and go into a room. You first have to go to reception. They have to check you in. They've got to get your ID, confirm it. Then they say, wait in the waiting room. Once everything is verified, then they'll send you up the elevator to your 5th floor. So Caddy is this like security check specifically for n8n. And then the important thing that we need to know is these port configurations. So at a high level, what we're doing here is that we're only letting an outside system communicate with n8n through this port. And we're not plugging that port into the outside internet. We're only letting it be active within this Docker computer, within this environment here. So that means that any traffic that wants to come into n8n can only come through Caddy. And then Caddy, we're giving access to the outside world. So the responsibility of Caddy is to be that bouncer. It's got experience with all sorts of different internet safety protocols. So that's why we're able to create these 2 ports that are able to accept traffic from the outside. So the flow would be a third-party system wants to interact with our n8n. It comes into one of these 2 ports. It goes into Caddy. Caddy verifies it, checks it, makes sure everything is good before sending it into n8n. So that means that this service actually never touches n8n directly. So you might be asking, what is port 80 and what is port 443? So these are very specific ports. Port 80 is for HTTP protocol. That's when you're sending the postcard that anyone can read. And port 443 is specifically for HTTPS, when you're sending that postcard, but it's inside an envelope. Now, when you're deploying n8n on Docker, for you to set this up appropriately, so you have like this air gap, so you have n8n and then you have Caddy, and n8n is only allowed to have traffic from your Caddy container, and then your Caddy is the bouncer that actually accesses the external services. To make these settings and these configurations, a lot of that heavy lifting is done within the YAML file. So if you haven't deployed via Docker, you might have a different, like your configuration file might be called something different. But at a high level, what you want to do is you can just take screenshots of this, or I'm going to post this, this file within my school community. You can take screenshots, upload it into your ChatGPT, put up your existing YAML file, explain what you want to change, and just say, hey, can you just show me how I would adjust my own file to reflect these changes? But at a high level, what you want to be doing is for your Caddy, this wants to be, or this has to be accessible by the outside, like by third-party services on the internet. So when you're mapping 80 to 80, this just means that any traffic from the outside can be plugged into the traffic on the inside. So like anything from outside of Caddy, so like the internet, can come into within Caddy, like you're just creating that tunnel. And same thing with 443 to 443. So that specific setting just means that you're mapping this these 2 services together. So anything from outside can actually enter into port 443, and it'll be routed into your Caddy container. Now, scrolling down to make sure that our n8n is not visible to or not exposed to anything within the internet, because we want that bouncer layer between us and the internet. You're not actually using the port. You're not saying ports. You're just saying expose. So when you say expose 5, 6, 7, 8, this port is just what n8n runs on. So it's like the default port. This is only visible within the Docker network, and it's not exposed publicly. So when you're launching Docker, within Docker, there's like this built-in network, kind of like a Wi-Fi system just within Docker. And when you're exposing this port from n8n, it means it can receive traffic from within Docker. So the next thing I want to speak about is this line here. So you may not have noticed this, but when you made your YAML file, you actually set the domain for your URL. So if we go into our webhook over here, we can double click into here. And when you see this URL, the structure n8n.salesy.ai, this is actually defined within the YAML file. That's one of the reasons why you have to do the DNS record, where you have to point your domain to the IP address of your server. That's exactly what you're setting up here. Then this protocol, the HTTPS, we use the envelope, is this protocol here. So n8n_protocol equals HTTPS. This tells n8n to generate these HTTPS URLs. And actually, the interesting thing is that services like Stripe or GitHub or Twilio will only send information to a HTTPS URL. So if you were to use the HTTP, that unsafe protocol, you won't be able to actually connect with these systems. So then we have the webhook URL, so the actual structure of that URL that we're used to. Then you can keep going through here, just take screenshots and put them into your chat GPT. And then I've left a summary going over the key things that we're doing in this YAML file. So now one final note, when you're installing your systems on Docker, like I said before, Docker is your computer. You can have this program for n8n. You can have this bouncer program that's protecting internet traffic into your n8n. You can also install other things on here, like you can have self-hosted LLMs. You could also have self-hosted vector databases, and then you can plug n8n into those systems as well. So then you can have free API calls for LLMs. Then you can have self-hosted, like nice self-hosted vector databases for your RAG systems as well. So actually Docker is very versatile and there's a lot that you can do here if you want to build out really cool systems. Okay, so we've gone over the high-level configuration you need for your server. Again, most likely you've set it up correctly, but I just wanted to dot our I's and cross our T's to make sure that everything is set up correctly. Now, the next thing we're looking at is the webhook security. So for our webhook security, I'm just going to bring a webhook onto the canvas, and I'm going to leave this totally unsecured. So I'm just going to go to make this a post request, and I'm going to be using the test URL for now. So I'm just going to copy that. And now I'm across in a tool called Postman, which is a way that you can test your API calls. So I'm just going to install this API call. It's a post request. I'm pointing it to this URL. And then over here, I'm going to say, I want to send a message key, and the value is just going to be hello. So now back in our n8n instance, I'm just going to go into execute workflow. And then back in Postman, I'm just going to hit send. There we go. And we had message received, which is workflow started. And now opening this up, we have the API call from Postman, and we can see over here, we had the message key and the value of that was hello. So we received our webhook event over here. Now, the interesting thing is that we were on Postman and we could just go into our webhook and actually access the workflow. So in order for us to install one of these pin codes, I'm just going to go to one of these authentication methods and I'm going to use header auth. And now let's actually create a new credential. I'm going to set the name as authorization. And then for the value, I'm going to put 1, 2, 3, 4, 5. And let's just rename this to Bart-test and hit save. Okay, so now we have some authentication requirement here. So we have a pin code on our webhook. And if I just come back on here and go onto the canvas and I click execute workflow, back in Postman, if I send the exact same message again, authorization data is wrong. And then we can see the URL actually wasn't triggered, which means that when we came to access the URL, we didn't have the pin code, we were not able to get inside. If I did want to access that webhook URL, I would actually have to have the appropriate information, so like the pin code to actually access. So the key we had was authorization, and then we had the password of 1, 2, 3, 4, 5. So our workflow is still active, ready to receive an event. And now if I hit send, there we go, workflow was started. And over in n8n, we actually received that and we were able to actually get into the workflow. So like I said before, there's heaps of videos on this already. I don't want to reinvent the wheel. You can go out and watch those dedicated videos. But at this stage, we've spoken about the server security and now we've spoken about the webhook security. So what I'm really interested in is now in the stuff that we can do once we get into the workflow. Because even though they've passed through the server, passed through the webhook, we now have even more dynamic control in the workflow to make sure, hey, is this actually coming from someone that we're expecting it from? And also, is the data correct? Is it in the right format? Are we expecting this? Is this going to break anything? And we just want to get really confident and comfortable with taking data or outside requests that are not meant to be in our workflow and just taking them and then putting them in the trash, but actually by logging them. We want to log all of these events so that we can see at which point is the system failing. For what reasons are API calls being denied? Why is the data not being allowed to come into our workflow so that we can go upstream and try and make edits to the partner service that's accessing our system from the outside? So the first thing I want to look at is this signature. So we just spoke about, we have this system with someone already passes our server. So we already spoke about someone comes into the webhook, they have the appropriate API key or pin code that we set, but now we also want to do a second level validation. So when you're working with services like Stripe, GitHub, Twilio, or for this video, I'm going to be demoing Zendesk, they can also send a signature. And then there's a way that we can actually take the payload that we're receiving from this partner account, so like Zendesk, and we can actually process it using these nodes in the workflow where we're comparing the payload that we're receiving versus the signature. And if those two things don't match up, then we know that we actually have to not approve that signature check. So this is like you and your friend have this special secret recipe, and your friend makes the hamburger using the secret sauce that only you have and that only he has. He makes the hamburger, he adds the actual secret sauce to the hamburger, and he sends it to you. Then you have to rebuild the hamburger in the same way. You add your secret sauce, which is the exact same as his, and you check the flavors. You bite them into them both, and you're saying, okay, they taste the same. It's coming from the same place. So that's a bit of a silly analogy, but we're actually reconstructing, like that's the mechanism that we're doing here. So the way that system works is that Zendesk sends us a specific payload. In that payload, there's a bunch of information, and some of the information includes a signature, a timestamp, and then the overall data that we're receiving is the body itself. So when Zendesk sends that API call to us, it can go through our webhook because we give it the same API credentials. Once it makes it into our workflow, we're then making sure that this in fact is from Zendesk and this in fact was not tampered with. Because let's say you have the postman, he gets your postcard, right? In this instance, we're not dealing with HTTP or HTTPS. In terms of tampering, that postman could actually get at your private information. And let's say you're requesting money from someone and you say, hey, Bart, send this money into my account. Here's my details. The postman can just erase your details and put his, and then continue that message on to you. And then you get that message, and then you think, okay, this looks cool. And then you complete that transaction, and it's obviously been fraudulent. So on our end, we have this process where we specifically take the timestamp from the body. We take the raw body from the actual payload from Zendesk, and we add them together in this specific format. And then we take the secret key that initially was like a handshake agreement. We met up beforehand. We're like, hey, for all our stuff, we're always going to use this specific secret key. So Zendesk uses it to generate their signature, and we're now using it to generate the signature as well. But we use this specific payload. We get the timestamp, add it to the raw body, run the mechanism against the secret that we have, and the output is a signature. So then we're comparing the signature that we received versus the signature that Zendesk sent us. And if they're exactly the same, then we know it came from Zendesk and nothing was tampered with, because if the body was a little bit different, if the timestamp was a little bit different, then, or if the signature, or if anything was different at all, even by 1 degree, then the signatures wouldn't match up. So that's what we're doing over here. So with these 3 nodes, we're actually running that entire process. So the first thing is we're taking the payload from Zendesk and we're turning it into a raw payload. So I'll trigger this off in just a second, but we have to initialize the raw body over here. When we receive a payload, it typically looks something like this, where if I go to JSON here, you can see that it's formatted very nicely, very easy for us to see. But when you're receiving payloads, the raw body, the unformatted, is actually just a really long string. So all this stuff, imagine all this is just on one line. The thing that happens here is when you actually like prettify this to make it easier for you to see, all these things, every time you have this like a spacing here and it goes to the next line, then this is the next line, there's these hidden characters that you don't actually see here. So what we're doing is we're taking this as it comes into n8n and we're converting it to the raw form. So we're stripping all these hidden secret characters, which basically give it a really nice format of what we see now. So we don't want these additional characters because that means when we create our recipe for the burger, we're going to have these extra characters that are going to make our signatures not the same. So that's what we're doing in this code node over here. We're just taking the data that comes in for the webhook, we're taking the raw body, and then we're just cleaning it up so it's ready for us to use. We then have to use this crypto node, and we have to run some validation. So I'm not going to go too deep onto this, but we're basically using this HMAC, where HMAC is hash-based message authentication code. We're running it through this type, SHA-256. And then for the value, this is where we're taking the actual timestamp and then the raw body. So the timestamp is just from the webhook that we're receiving. The raw body is from that code node just in a previous step. We paste in the secret key over here. So those 3 things were the timestamp, the raw body, and then that secret key. And then we're using base 64 to encode. So you can take a screenshot of this. You can find information. You can just take this, put it into ChatGPT, and you can get it to explain this for you. Or if you want to use this specific setup, this specific authentication method, then you can also ask it to explain for the tool that you're using. Now, at a high level, just to also be super clear here, when you're using one of these nodes, like, let me just zoom out, something like Action and App, if I was to use something like Zendesk, create a ticket. So this is a pre-built node from, this is actually not a webhook event one. I just want to be super clear here. So add another trigger. Let's go from on app event, and let's go Zendesk. Okay, on new Zendesk event. So when you're creating a trigger like this, I'm pretty sure n8n under the hood is going to use this sender signature method. So all this like complexity stuff that we have here, it actually automatically does that. I'm pretty sure. I actually haven't looked into the code, so I can't be certain. But because of like safety protocols, I think n8n would just default to this. So you don't actually have to do this check here. It should be built into the backend. But when you're doing triggers, some of the events you might want to send might not be built out in the tool that you're working with. So in that case, if you're just sending a webhook, like to a webhook event, you might need to do this as an extra layer of security. So once we actually produce this specific, the key that comes out of here, the signature, we then use this if node. And all we're doing here is we're looking at the output of the crypto node, and we're comparing it to the signature that we got from the headers from the webhook from Zendesk. So basically we have the output of that crypto node that gives us the signature, and then we're using the if node to compare it to the signature from the Zendesk payload. If those things are good and it equals to true, we will then take the next route over here, and we can speak about that in a second. And if it's not true, we're taking this false route. I actually like to use it. This is just a do nothing node, so it actually does nothing. I just changed the name to make it super clear. We take the fail signature route, and then we log that event in Google Sheets. Now, you should actually always log these events because you do want to see why upstream something is happening. So let's say we're doing this for that authentication method, that really advanced one. Well, we want to know, okay, if it fails here, why is it failing? Because that means someone that is not Zendesk sent it, and that means someone that tampered with the information sent it, like someone tampered the info. So we might want to see like who is doing this. We might want to find out what information did they tamper, what are they trying to access. But the main thing we probably do is change the URL and change the authentication. So you would come into here, you would just delete this webhook, reinstall a new webhook. You would go into here, you would change your authentication credentials because this malicious party knew your authentication credentials. So you would change this, and then you would go into here, and for your webhook coming out of your service like Stripe, GitHub, whatever, you would just go into there and generate a new secret key. And then you would install that secret key into your crypto node because this is the main thing you have to update. So that's what you would do if you actually had a failure event over here. So this is super important that you understand why these things are failing and why these things are happening. So now another thing that we can do is actually manage the payload. Now, some of these things will make a bit more sense in just a second. Like this stuff, the process is actually going to run when we set up the Zendesk webhook. And this is also going to make more sense a little bit later. But at a high level, we're coming into here. And the purpose of validating the payload is, so let's say, for example, in Zendesk, I'm going to set it up so we only want to receive new ticket events. So in here, I'm actually checking that the event that we're receiving is called ticket.created. This is a very specific event. So this workflow only manages new tickets. We want to do a specific set of steps over here. If we receive into here, for some reason, an event that is not this, so for example, a ticket solved or ticket closed, well, we don't want to run it through this exact same process because we might generate a reply in this ticket created workflow. And that means if someone closes a ticket and they get a brand new reply, they're going to be very confused. So we want to be very careful with the data that we're putting it into our workflows. So a very basic check is to see, hey, is we're receiving the right event, or is it in the right structure? So that means if you're expecting a certain payload, maybe it actually has 5 different keys that you must have for this workflow to be active. So you just might map all these as if conditions into here, and they all have to be met in order for you to proceed. Once again, if it doesn't actually match and it's not a ticket created event, log it. Go into your Google Sheets and log it. So that way you can see, okay, what event is Zendesk sending us? Okay, they're sending us the wrong event. So you go into Zendesk, you reconfigure your trigger over there, and you make sure that you're only sending the right info into here. And by the way, your stuff when you're logging it, like if you don't know how to log things, it can just be super simple to start with. For example, I'm just using 3 columns, the error date, the error time, and then the error reason. So the date is just in my local time zone. It's just a date like this. Then I have my local time, and then I have what the reason was. And the reason is literally based on wherever it fails. So if it fails here, it's a failed signature reason. If it fails here, it's a failed data reason. That's what I've got: failed signature, failed data. And then if this is the complexity, if this is how sophisticated your initial system is, so be it. Run it through, see what's failing, build it out better. Just start with something. So now, some of the values of actually doing this payload verification, validation is, okay, the format's correct. It's the same data that we're expecting. You manage your API costs, because if you just kept putting all the events into here and you didn't even know that you're sending 5 different event types, not only do you risk actually customer issues, so you're responding to all these tickets when you shouldn't be, but you might be doing LLM calls, and you might be just wasting money on LLM calls that you shouldn't even be spending in the first place. Also, database integrity. So as you're logging these events, well, you don't want to be logging the incorrect ticket events into your ticket. So let's say here your database is ticket is created, we generate our first response. all you want in that specific Google sheet is just to see what ticket was created, what response the AI generated, and then you might be comparing that. If you muddle it with tickets that are closed and you're generating replies, well, you've now just infected your database with incorrect information that isn't relevant to you and doesn't help you actually reach your goal. So those are some of the values that you get when you're actually just doing this payload validation. And for me here, literally just looking at the event type is enough. So very simple if node, very simple check. But massive value for cost, massive value for customer impact, massive value for database, and just you're not breaking your workflow in case something doesn't really make sense. So it is a really good, it's really good to do this stuff. Now I'm going to touch on these 2 points very quickly as well. There's actually a bunch of webhook security information you can find online. So this is not the full extent of stuff that you can do. I just want to give you an idea of things that you could do to get started with easy stuff. So you could also check for the timestamp. So pretty much every webhook you get typically has a timestamp somewhere. So let's see if this Postman one had a timestamp or something here. User agent, content length, authorization. Okay, maybe it doesn't have one here. But the point is that when you send your API call from these third-party systems, like an actual API call, will have a timestamp of when it was sent. If you receive that event into your n8n webhook, typically that is instantaneous. Like within a second, that event goes from the source to your n8n scenario. So if you're expecting it within a second, but it takes 5 minutes, well, you might say to yourself, okay, something seems a little bit fishy here. I'm not really sure what happened. Maybe the data point expired and you can't really use it, or maybe someone tampered with it and they kind of got through your system anyway. So in this case, you might not accept the workflow, or you might put it into like a separate queue where it checks. So if the timestamp is true, it goes into your main workflow, it generates a response for the customer. If it's false, it goes into a separate workflow or a separate bucket where you might have a human in the loop to just verify that. And a human comes in and they say, oh, okay, yeah, no worries, it took 5 minutes, that's totally fine for this one. And they might just give it a green tick, and then it goes back into your main queue, and then it gets executed. So you can still gracefully handle these events. But that is one method for like another webhook security method. Then you have also event ID. So this is a really interesting one. Let's say you're building out an app that has Stripe integration, and Stripe is hitting your webhook and it's telling you, hey, Bart just signed up to your event or just purchased your product. Please charge him $50. So in this case, we can actually inspect the payload from Stripe and see what was the event ID. The event ID is always unique to that specific event. So maybe by accident, Stripe system stuffed up and they double sent it to you. If you didn't actually check the event, so in this specific instance, you would take the event ID, you would log it to a database, and then you might have a check over here for events that takes a new webhook, takes the payload, sends it off, like logs the actual event ID in the database, but compares the event ID. Did we have any of these already? Because if it's unique, you should only have one. If one already exists, it just means that, okay, it was a duplicate API call. We shouldn't actually process this one. So to handle it gracefully, you could either just can it immediately, or you could put it into a human in the loop, and maybe there's some reason that it was doubled up for the event. But the concept here is that, instead of double processing API calls, you can just make sure that everything is uniquely processed. So these are some more features, or there's some more security steps you could do. So another thing that I actually didn't mention here, which you may have come across, is like rate limits for API calls. Some of the services that you're using, if you're using OpenAI, if you're using OpenAI and you just signed up and you have like a level 0 account, you're going to have lower API calls, which means the amount of API calls you can place per minute is going to be more restricted. So let's say your maximum is 10 API calls per minute. They're basically OpenAI is throttling you. They have a mechanism to only accept from your specific address 10 max per minute. So let's say you have a malicious person and they somehow find the information that gets access into your workflow. Well, they might just start sending heaps of requests, right? And they could send 5, 10, 15, or 1,000 in a minute. And if all of them keep getting through, then that might mean that before you actually catch it, they've just spent through 1,000 LLM calls and it might cost you $1,000 in costs. So actually one thing you can do is rate limiting. Now, rate limiting would be completed by one of these types of services. So I think on a workflow level, you could possibly use something after it hits the webhook and send it off to this rate limiting service. But really what you want to be doing is using this air gap over here to actually rate limit before it hits your webhook, just by the way. So what that means is that this security guard bouncer would be the person that's rate limiting. Caddy, I think, can rate limit, but there's other providers that, like another system, like a different bouncer that's specialized in rate limiting that you might want to use. But yeah, this is where you would set it up. So that means that whenever a specific person sends some traffic into one of these ports, HTTP, HTTPS, you will have like a requirement here that says, hey, if too many requests are coming from one specific address, we want to ban them. Or we just want to process 20 max at a time. So rate limiting is yes for security, but it's also maybe just for workflows in general. Like in your n8n YAML file, you can also set how many workflows max you want to execute at one time, just for like performance reasons. So that rate limiting could, there's multiple reasons why you might do it, but it's also for malicious people trying to send 1,000 API calls at once to just make you rack up lots of LLM credits. So now the final thing I want to do is just set up a Zendesk API call that goes into this webhook and just show you this entire process of how it looks with the data. So I'm across in my Zendesk account. I'm going to go to Admin Center, and then I'm just going to go to here and type in webhook. So I want to create a new webhook, and a webhook is just basically, it's like having a phone number. So on top of my webhook, I have to create an event or a trigger so that it gives it a reason to actually fire off some communication to the webhook. So I'm going to choose Zendesk events. And for this, I'm going to go ticket events. And this is not so important for you to know. I'm just going to go ticket created. So now every time a new ticket is created in my instance, it's going to fire off this webhook. And that webhook is going to send some information across to my n8n instance. So now I'm going to go to next. Let's call this Bart-test for our endpoint URL. We're going to come here and grab this URL. Let's go to the test URL. It's in post. So we have this test URL. We're using the post method. We're actually logged into this. So we have to make sure our n8n webhook is using this method, which it is. Now I'm going to go for API key. And we're just going to use the same authentication from before. So we're going to go authorization header, 1, 2, 3, 4, 5. So that means in our webhook, we have to come back here and use the Bart test. That's the same one that we set up at the start of this video. Okay, cool. And now I want to test the webhook. So then over here, we have the example body that we're receiving. So this is not actual real ticket information. This is just completely made up. But the actual structure, so like account ID, detail, actor ID, all the stuff on the left-hand side, this light green color, is exactly what we're going to receive from Zendesk every single time. And the stuff on the right-hand side, that's the dynamic stuff. So depending on a ticket channel, it might say it's from emails or SMS, depending which group, depends which customer. So the stuff on the right-hand side will change. So let's open up our webhook to be receiving events. And I'm just going to drop down here because I want to use the development webhook. I'm going to go, boom, open it up. Now in Zendesk, I'm going to go send test. Nice, workflow was started. So now we receive the packet of information from Zendesk. And since we had raw body, we actually get the binary data, but we can go to JSON and actually see what information was sent. And we could see here, this is the body, the account ID, all the stuff that we saw before, all the way down to, I think here, that's the actual payload from Zendesk. So in our earlier graphic, that's the actual payload that we're receiving from Zendesk. And we received it into our n8n scenario. We had the authentication key, so the authorization header of 1, 2, 3, 4, 5. So we were able to get into the webhook, but now the second layer of security is here. So now we actually failed this authentication because I never put in our secret key. But just so we see what happened over here, we had the data that came in from Zendesk. We converted it into the binary format. We stripped away all the special characters, and then we received this raw body over here on the right-hand side. So now going into the crypto node, we got that information from the Zendesk. So we had the actual signature, we had the actual timestamp, and then we also had the raw body from the code node. We processed it using the secret key, which was actually incorrect. And then in our if node, those two things didn't match up. So we actually took the false branch. So in order for me to get the secret key, I have to come back into here. I'm just going to go create webhook. Now I'm going to go back into the webhook that I created. And now I have this additional secret key created for us for our webhook. So I'm going to go to reveal secret. I'm going to copy this. Back in my n8n scenario, I'm going to update this secret, backspace this, paste it into here. Let's hit save. And now if I come back into Zendesk, I'm just going to go and test this again. So I'm going to go test webhook. And now I'm going to come back into here and open up my webhook. And from Zendesk, I'm going to go send test. Okay, awesome. Workflow was started. Now we actually have the successful route. So if we go back into here, once again, just the binary conversion of the data that we received. We then ran through the same process as before. So we got the timestamp plus the raw body. We had the updated secret key. And then our if node returned true because the signature that we got from Zendesk and the actual signature that we created ourselves using our secret recipe was actually the same. So we took the true branch. But then now over here, we got into an error because I haven't configured my AI agent. It's just outside the scope of this demo. But if I come back into this if node, we actually had the event type was equal to ticket created. So if I actually just go back here and I open up this webhook and I go into JSON, oops, nope, I'm in the wrong one. The webhook, no, I want to go JSON here. There we go. I should be able to find the ticket. What are we looking at? Event type. I think it's down the bottom here. There we go. I'll just zoom in. We had the type, which is Zen event type, which is ticket created. So that means that this whole information that we received is from a brand new ticket. And that's what we got over here, brand new ticket. So if I actually just change this to ticket.solved, we would take the false branch, we would log this and not process the data. All right, guys, thank you very much for watching this video. If you want to access any of these resources, like this template or the actual YAML file, I'm going to have it available in my school community. And if you've actually watched up until this point and you are interested in improving your technical skills when you're building with n8n, like if you didn't know any of this stuff existed, but you found it very interesting and maybe your clients are asking about this, or you want to run workflows for your business, but you're scared about what could possibly go wrong if you're actually running in production because you just don't know this stuff. This is the exact type of stuff that we're actually speaking about in my community. I made this video because last week on one of our calls, one of the community members spoke about this, and I thought, okay, I'll just put a very comprehensive deep dive that covers like the majority of areas that you should know if you want to start building workflows. So for more conversations like this, definitely come join the community. I've got a 7-day free trial, so you can jump in, jump out if you want. All right, guys, thanks very much for watching, and I'll see you in the next one.